Okay, for C, for time less than 10, so I assume that means between 0 and 10 because we can't do anything until we take the potato out of the pot. So for time less than 10, an alternate model for the internal temperature of the potato, you should be used to this by now where they give different models, is the function g. G satisfies this differential equation. G of t is measured in degrees Celsius. So we really have exactly the same situation we started with, just a different model. When we first read the problem, we said they're giving us a formula H, and then they're giving us the fact that H satisfies this differential equation, which means they were giving us a amount formula for calculating the temperature. And they were also giving us a rate formula for calculating the rate of change of the temperature. The rate of change would be degrees Celsius per time in this case is measured in minutes. Well, we have exactly the same thing in part C, except that the amount formula is G of T. So that's how we can calculate the temperature. And our rate formula is the differential equation dg over dt, which is this right here. So exactly the same situation at the beginning, just new formulas that they want us to use. So go back to C here. Find an expression for g. Okay, stop there. If you are starting with the differential equation and you're trying to find the equation for the amount, that's the SASSY method. So they want us to do that. So you should stop reading and do that first. So we want to use the SASSY method. We're going to solve this differential equation. So the output variable is g, the input variable is t. So we separate, that gets us 1 point. To separate. We've got the output variable g on the left, the input variable t on the right. Now we've got to find the antiderivative of those. I didn't like trying to find the antiderivative with this in the denominator, so I moved it to the numerator. That makes the exponent negative. Now I can use the ax plus b version of the power rule. So I have, let's see here, the a is just 1 though, so that'd just be 1 over 1. Here's my negative 1 out front. Ax plus b to the negative 2/3 plus 1 divided by the same. Over here, the antiderivative of dt is just t. If you get the antiderivative, you get a second point. Dividing by 1/3 is the same as multiplying by 3. So then multiply by the negative 1. So either green box would get you the 1 point. This lower green box is a little easier to work with going forward. So now we're going to do the constantate steps. We do the separate, anti-differentiate. Now we're going to constantate. So we take our formula, and we know that the value of g is 91. The value of g is 91 when the time has a value of 0. 91 minus 27 is 64. 1/3 power means cube root. Cube root of 64 is 4. That's how we discover that c has a value of negative 12. If you find the value of c, you get 1 more point. Now we're into the isolate step, SASSY. So we've got to get the g alone. So we go back to our formula here for g. We rewrite the formula, including the value of c now. So that gets us here. And they scored this one a little different than typical. They actually gave a point if you got that far. You don't even have to isolate. You just had to remember to plug in the c appropriately. So that's good news. That gets you 4 points to that spot. Now if you're trying to get the G alone to get this very last point, let's see, we've got to get rid of the 3. So we multiply both sides by negative 1/3. That got me to here. Now we've got to get rid of the 1/3, which means that's cube root, so we've got to cube both sides. So we cube both sides. Then we would have to add the 27. Then they say, what is the internal temperature at time equal 3, which means plug in a 3. You don't need to do any simplification, so if you get right here, where you've plugged in the 3, well, here doesn't count yet. Here's isolating the G. You had to do that and plug in the 3, and that's how you got this 5th and final point. So 5 points total.